Question 32. A farmer wishes to make a rectangular enclosure of area 720 square meters. She uses an existing straight boundary as one side of the enclosure. She uses wire fencing for the remaining 3 sides and also to divide the enclosure into 4 equal rectangular areas of width x meters as shown. The total length, L meters, of the wire fencing is given by L equals 5x plus 720 over x. Do not prove this. Find the minimum length of wire fencing required, showing why this is the minimum length. The first step is to rewrite the equation using a negative index, which makes the differentiation of L with respect to x easier. So L equals 5x plus 720 times x to the power of negative 1. The next step is to solve the equation dl dx equals 0, where dl dx represents the derivative of L with respect to x, which is 5 minus 720 times x to the power of negative 2, which is equal to 5 minus 720 over x squared. So we're going to solve the equation 5 minus 720 over x squared equals 0 to locate any stationary points. So I'm going to multiply all terms by x squared, and we have 5x squared minus 720 equals 0. The next step is to add 720 to both sides of the equation, and we get 5x squared is equal to 720. And then dividing both sides of the equation by 5, we get x squared is equal to 144. Now x represents a length, so it needs to be positive. Therefore, x equals 12 meters, and this corresponds to a stationary point on L. The next step is to determine the nature of this stationary point. So we're going to test dl dx, where dl dx equals 0, around the point x equals 12. So I'm going to use a table of derivatives for this. So the first row are values of x, where 12 represents the value of x where there's a stationary point. And I'm going to pick 2 convenient points around x equals 12. So I'm going to pick x equals 11 and x equals 13. So the value of the first derivative when x equals 11 is negative 0.95, which is a negative gradient. And the value of the derivative when x equals 13 is positive 0.74, which is a positive gradient. And based on the results in this table, x equals 12 represents a minimum. Therefore, the minimum length of wire is equal to 5 times 12 plus 720 over 12, which equals 120 meters.